Okay, we are on the air. This is the March 16th, 2015 e-NABLE R&D Hangout, and um, it looks like we have the beginnings of a full house. We've got a few more people that might be joining us, but if anybody has anything they want to start with, feel free to bring it up. I guess Jeff Aronstone and Jeremy Simon and Skip Meats had mentioned that they had things they wanted to show, but that maybe something got broken and they might not be able to show it. But I figure broken things are just fine to show. It shows progress and it shows where the design is going, if nothing else.
I have some scrounging things to show.
Well, I could definitely get us started here.
Okay, feel free.
So it's sort of a what Skip and Jeremy have been working on that has broke is a new terminal device that can be utilized with kind of a conventional prosthetic. Essentially, just sort of screws into a conventional prosthetic, much like any other terminal device. More or less like the hook that I have in my hand right here. It actually just threads right in.
Okay.
And the terminal device that they're working on will have the same thread, so that it could just thread right in. So conceivably you could take this off and then take a hook off and put a hand on. I think they're currently working on a flexi hand version, but I know that they have off and on been working on a Raptor version as well. So that's the side that they've been doing. What I've been doing is the Monet socket, which I kind of published over the weekend, which is so here's actually what I published, and once again it has the same thread, so you can just sort of thread in a terminal device kind of directly to it, or you could have a kind of a forearm section that you would also thread in, and something like it could just be like a standoff. At a certain point here, I could post a part from McMaster car that anyone could order, and you just sort of bolt it in on both sides, and then it makes a forearm section. The one I'm going to post is not a cheap one, but there are less expensive ones.
All right. Is that thread in standardized size?
Yep.
Between?
It's
okay.
half inch, 20 thread. So in other words, there's 20 threads per inch.
Okay.
So it's a fairly standard size.
I had assumed that it was a standardized, but I wanted to make sure that was clear in the recording.
Yep. No, that is a very standardized thing. So anyone else who wants to make a terminal device, that's sort of the term that we use. If you want anyone else who wants to make a terminal device, and then thread that on. So, for example, what Bob Roth is working on for the welder patient of mine, he's also going to have that same thread.
Right.
This is actually the hook that belongs to that welder patient, this is sort of a kind of an elbow component that he utilizes as well. So just sort of it makes the whole arm modular. So then, kind of going back to that, it's sort of weird. I published the Monet socket, but it's not so much of a thing as it is a concept, because the thing itself is very rudimentary at this point in time. What Skip and I kind of discovered, about 2 months ago, is that taking PLA and then heat forming it, heating it up to kind of high temperature, and kind of anneals the layers of the PLA together better and makes the PLA strong. He first kind of realized this when we were playing with this sort of flat pieces of PLA that he kind of dubbed PLA plywood, and then has been kind of doing some heat forming, just lower temperature heat forming of that, but by the way that he's laid out the fibers of it, it made it nice and strong. This, what this is just a cone shape that I posted, then heated up with a heat gun that is as about 1,000 degrees Fahrenheit. You got to move it around and stuff like that. And by doing that, it makes the whole thing just floppy and mobile. And then you can actually with gloves on manipulate it to kind of stretch it and then form it over a model. Now that does two things. One is that you get a custom shape. I mean, you can kind of see how this is just a very detailed custom shape. But once again, it anneals the layers of the PLA better, so that it's much stronger. I mean, this is probably about 1/16 of an inch thick. And
it reminds me of the principle that they use with ABS when they're doing the vapor bath with acetone vapor. It creates a stronger cohesion between the layers, and because the acetone vapor slightly melts the ABS, and your heating is creating a similar.
Vapor bathing has pretty negligible, to my knowledge at least, I would assume it's negligible, effects on the strength of the part because it doesn't penetrate like at all, but it does make the part much smoother.
Right.
And while I have the mic, it totally makes sense that what you're saying would work, sort of annealing, because by far, I mean, the only reason that printed parts are anywhere near as weak as they are is that there's imperfections inside of them with air in there. So heating them up and sort of letting that escape a bit by mashing it around, which it sounds like you're doing as well, would certainly toughen them up.
Yeah, it does. It toughens it up quite a bit. Yeah, and as you mentioned that it's I guess the difference between that ABS procedure that you were just talking about and this is that I'm heating it all the way through and then kind of hand working it. Essentially I'm hand forging it as I'm kind of manipulating it around. So it utilizes some of I've been incredibly impressed of the strength of PLA after you work it for a while. And one of the most, compared to some of the other plastics I use, the more you work it, the stronger it gets. It really does. So I just posted something. So here's a Raptor that I kind of took a cone, and gosh, I probably heat formed this thing probably about 10 different times. And eventually I got this, kind of odd, partial hand shape that I have here.
Nice.
And, once again, it's very strong and very custom shaped.
I don't know if I missed it. What temperature are you using for that?
Well, I'm using a heat gun. The heat gun it goes up to 1,000 degrees, but it's a conventional heat gun. You can buy one from at Harbor Freight for $15.
So you're not baking it in an oven at all. You're just applying heated air to it.
Yep, I'm not baking it. I mean, the only thing baking would do is just what I've found that baking it is good to get the process started. It makes it so that you have to be less dynamic with a heat gun. But just rotating it around with a heat gun and just sort of just constantly working the heat gun and just going around and around and around and around. That's the thing.
I have given some thought, on this printer bod. It's got the fan on the side. I'm giving some thought to moving the fan slightly and putting some resistors there to create a hot air vent down onto the part in lieu of or in addition to a heated bed on my printer. I mean, I think heated air and heated environments and things like that make a lot of sense especially for like PLA or for ABS and other materials that require heated environment of some sort.
Yeah. So here's another cone. And I actually just I'm about to post a video of me heat forming this cone. And much like that, I have kind of a threaded nut in there. So it's sort of a two-step heating process. You heat the main part of the cone, to the shape of the model, and then you kind of put the threaded nut in there, just a flange nut, just like this,
Mhm.
and then you heat the top and just sort of mold the top of it, the plastic down around it, and it contains it and supports it.
Right.
So, I just see, I could see a lot of different applications, a lot of things I haven't even thought of necessarily, but like I said, you could do an attachment on the side. So say, just imagine, take some, where you have sort of a spot to put a nut on the side. So
Right.
you could heat form that. That's kind of put the nut in on the side, heat form the side a little bit, and then you have it ready for it just to kind of be put right down into a Raptor and bolt right in.
Hmm.
Sort of a more solid extra attachment point. I mean,
Yeah,
solid than the other one we were talking about, which was the Picatinny printed rails,
Mhm.
which
yeah,
are
yeah.
fairly rugged,
Well,
but
I,
not
I was
as rugged as
I
that
was
one.
thinking along the lines of on the inside.
Okay.
Uh, just to make a more custom socket, kind of like what Aaron Brown was doing with the mesh, that he was using. That was sort of folding the mesh over.
Right.
It's a similar concept, and I liked what he did there. It's just another way to do it. That's all.
Somebody did do some kind of a socket for little hands for it when they're not big enough to deal with just the Velcro. It's been quite a few months since they started doing that. I think it was a Cyborg Beast thing, but I'm not sure. Anybody remember that?
Vaguely, and definitely makes a lot of sense to me. Wouldn't be able to give you a link, but
Hey, Bob.
Yeah. Okay.
Yeah. Well, I think I think this has some applications with the Cyber Beast and the Raptor that but I'm not sure it's appreciably better for those than the what has been done with the mesh, or the other things. Where it becomes a big deal is with when we get to the transhumans, like the RIT arm and stuff like that, because to make a custom socket shaped like this, the printed designs that they've done in the past weren't nearly as strong, weren't nearly as custom, and were pretty thick and heavy. This functions much better in that regard. So that
Mhm.
for a trans radio, I'm saying it's a game changer.
Mm-hmm. I was curious, what about, have you had a chance to work with any of the flexible filaments to do a socket? Because I know that Steve Wood was at least presenting the idea of doing various sockets using the flexible materials.
Yeah, I mean, I haven't toyed with doing a socket yet. It definitely is on my radar. Yeah,
Okay,
I would worry a little bit about it kind of flexing the socket itself, flexing away and kind of making points of pressure
right,
on the distal bone or something.
yeah,
I mean it does. So here's a flexi hand in process.
uh-huh,
So
hmm
even at this thickness, it does kind of bend and gives. Now, with that said, I've kind of been toying with the thought of some kind of, flexible socket, but then having some outer
so
helilated ports or something like that.
first of all, Flexi, whatever this stuff is called, Flexi,
there's
Filflex.
Ninja and
yeah,
Filaflex.
Filaflex, Flexi filament, whatever you want to call it, as a socket kind of skeeves me out because, to my knowledge, there isn't a good way to smooth that stuff, and I think unsmoothed printed parts in body contact are a pretty seriously bad idea because they're just a fantastic harbor for bacteria to grow in. And plus, they probably just get pretty gross, to be honest. But on the topic of non-rigid sockets, I really like the way that the super expensive, like Bionic Island kind of stuff do it. They so what they've got is essentially a silicone, like cloth with silicone on it sleeve that goes on the arm, and they've got a socket on the end of that sleeve. and then to attach it well, they have a little manual pump built into the forearm somewhere that you just tug on a few times, and it actually applies suction inside of that sleeve. So you end up with this really strong seal on it. And if you've seen the video of the girl with the non-myoelectric, just a rigid hook, transradial prosthesis doing gymnastics, she's like swinging on bars and stuff with it. That was done with that method, so it's obviously really, really strong.
Yeah, that is certainly one way to suspend a conventional arm. Definitely, there silicone liners is the term we use. Silicone liners are very heavily utilized these days. Almost 99% of all legs utilize a silicone liner. I'd say about 60 to 70% of arms utilize a silicone liner.
Hi, Jeremy.
How's it going?
Not so bad. So Jeff, you were mentioning with the PLA plywood material that the more you heat it up, the more rigid and strong it becomes. I suspect that's similar to when people were talking about ways to recycle printed parts back into new filament, that the more times you reheat it to try to make it into filament, it gets harder and harder for it to be printable. And I'm guessing that's the same property that you.
Yeah, so that's kind of, it's a mix of burning off volatiles in the plastic and I think it actually changes phase somewhat. There's I don't remember how exactly it works. There's a glassy transition that PLA can undergo under certain conditions where it gets much more brittle and stiff. If you're doing retraction wrong, this will happen inside your nozzle and give you a really bad day. But I think it's just if you get it hot enough while molten, it'll recool into that state. So yeah, probably that sort of stuff.
Yeah, I mean, I haven't gotten it to the point where it's brittle yet. But I'm also heating up slowly and cooling it slowly. So.
The lots of layers probably helps because the heat doesn't penetrate through all of the layers. So you're probably going to get some rigidity on some layers and less on others. And the heat will permeate a bit, but you're going to lose the amount of heat the farther in it penetrates.
Yeah. But I mean, sort of this is just a very thin piece of, essentially what would, PLA plywood, let's say, and it's, so I just broke it, but right there at kind of this.
Right, that's what the hole is.
Yeah, but it does pretty well.
So then, if I can change topics here. I've got this kid at Cornell that really wants to get involved in e-NABLE stuff. And I seem to have mostly sold my advisor and giving him credit for it. So I think I'm going to have him, losing all my words. Oh, I think I'd like him to standardize our myoelectric stuff, basically. So right now, correct me if I'm wrong, all the do-it-yourself myo hands we've seen are like a little board about this big that has a myoelectric amp on it, a little board probably about that big that's your Arduino, little boards about the same size as the myo one that's doing your servo control for the Arduino, and a little battery pack. Now, with the exception of the battery pack, there's no super strong reason that I know of that we can't pack all those onto a single board. There's probably a little bit of like interference troubles to be figured out with sensitive myo and servo control on the same board, but I mean, how precise are we really making this stuff? So he's probably going to be working on that this semester, and hopefully the result of that is that at the end of the semester we have a board that we can just order from, say, like Osh Park or one of the other cheap manufacturers for like, I don't know, 15, 20 bucks. And it's pretty plug-and-play myoelectric setup. Controls the servo, takes a little nice plug of some sort to connect your electrodes. Should work pretty well. And
what
then,
Arduino is used in that? Well, which Arduino is using that?
Probably just a Pro Mini socket. I'm not sure yet if I think he should integrate a little Atmel chip right on the board, or he should let people slot in a socketed Arduino board.
Oh.
Nick?
Yep.
What do you think about, well, I mean, you don't have to say right now, but it occurred to me, Albert Monero from Limitless and Ali Lemus with the Galileo hand and the other people who have been sort of, forming groups of people working on that. It might be good to see if maybe
reaching out to them.
Yeah,
I certainly intend to do that. Are any of those designs fully open? Do we have designs and documentation for them?
I think so. The Limitless ARM is on the e-NABLE site on enablingcomputer.org. So
yeah,
at
then
least
it may
that
be.
one is.
I mean, if it's up there, that obviously works quite well. So it'll be a simple question of having him miniaturize that.
Mm-hmm. Yeah, well, I was just thinking maybe they'd have some insight to add to whatever you guys are working on.
Yeah, certainly.
I had some experimental circuits also that you might want to look at. I put them on the forum.
I fooled around with basically following the reference circuits for various instrumentation amps over summer at Amory. I'll take a look though. It's probably pretty relevant. Again, I'm not doing this myself. I'm kind of pushing this BioE student onto this project. But yeah, I will forward these things to him.
Certainly.
The thing that got my attention really, what you said was talk to your professor into giving school credit for working on an e-NABLE project. That's a major bonus. The more we can do that.
I think that's easier. I don't think it's that hard to convince a professor to do that. I mean, you look at the attention Frankie Flood over the Milwaukee has gotten for e-NABLE stuff.
And just Albert Monero.
Yeah, I mean,
attention to as a college.
It's pretty easy to be like, look, this project will cost you $200 in that grant you're not going to use anyways, and it'll get you way more attention than all of the actual rigorous research you do. So, not actually the case with my advisor because he's a little bit famous, but I mean, for most professors that should work.
I'd be interested in seeing the results of work once he gets started on that anyway.
Yeah, it's
certainly
going to be a challenge a bit integrating those because of the low noise of the amplifiers. I did a little reverse engineering on that board.
The SparkFun one?
What's that?
The SparkFun board?
Yeah, I think so. Well, it's a board from, what is the name of that company? It's been a while since I looked at it.
Yeah, hold on, I can look it up again. SparkFun makes them, but they're not the only ones. Originally, it
was designed as a college project, a senior design project from this guy, and he formed a company around it. And then SparkFun makes the boards. I think it's the story.
Yeah.
It's really a very straightforward circuit, but the input signal varies from 0 to 1. I think it was 1 millivolt, and the output signal is a few volts. So there's a lot of gain there, and then when you're trying to, obviously you need to understand the problem of when you're trying to interface a digital circuit to such a sensitive amplifier. You got to use separate grounds, separate power supplies. Look at your decoupling and look at your make your traces orthogonal and things, all this kind of stuff.
Yep.
But I'm sure you're aware of those kind of things. I just mentioned them to get them out in the air.
And and the thing is, there's professors that do really advanced research on this stuff at Cornell. So I'll probably have him reach out to some of them. The other thing that I kind of want to see tried is, to my knowledge, all of the Mayo stuff we've done so far has been using Arduino ADCs, I guess you'd call them, the opposite of a DAC, analog to digital converters. And those things are like, I think 6-bit. They're really not precise.
For 10 bits.
Are they? Oh, well. Anyways, I mean, I have to
I don't know
imagine.
how accurate they are.
Yeah, right? I have
Because they
to
have
imagine that.
to get 10 bits out of it.
Mm-hmm. I have to imagine that a little like I2C kind of
Advanced
ADC would work much better and let us do a lot more interesting things. I mean, if you look at the SparkFun design, they're smoothing the hell out of that circuit before they ever pass it into a microcontroller, which is arguably throwing away valuable stuff, or it might just be throwing away noise. I don't really know, but certainly something to be curious about.
I think what you said is a really smart idea because it sort of attacks the noise problem from the other side. From the input side, you've got something sensitive looking at the noise, and then you got something really accurate looking at the output of that thing before you digitize it. So it's like a double approach at reducing the noise.
Yeah.
So that makes a lot of sense, yes.
So if we're really lucky, like really awesomely lucky, there will be a reasonably cheap I2C kind of ADC that gets us enough accuracy that we can start doing magnitude stuff. So flex a little bit, grip a little bit, flex a lot, grip a lot kind of stuff. And that'd be really awesome. But not sure how feasible that is. So that's my thing, I guess. And the sort of vague hope is that after I get this guy to do e-NABLE stuff at Cornell and probably get some not insignificant amount of attention from campus media and the like, that next semester after Hob leaves, it'll be very easy for him to find a actual bio-E lab to keep doing e-NABLE stuff in. And then I'll have some place to point people towards when I meet them at Cornell, and I'm like, oh, you should totally work for e-NABLE.
The company that originally made the SparkFun chip is Advancer.
Right.
Right.
That's it. It's a very straightforward design, very simple, straightforward, and nice design, except for the obvious over-filtering like you talked about, yeah. And the fact that they even do the filtering and the rectification on the board kind of like makes it single purpose. But for that purpose, it's great. Would you like me to go next?
For free.
Okay, thank you, sir. I have had my hands tied not having access to my electronic stuff. So finally Saturday, I went with my buddy Raul to the storage shed and got some goodies. These goodies include some hand tools, a soldering iron, it's a Weller soldering iron. Did I say Weller? Yes, I said Weller. Always wanted a Weller soldering iron, so when I bought that thing, I was proud. You see me play with this thing.
Planetary gears.
So I can make gears now, if we should need them. Some breadboards, an Arduino Uno R3. Got my hands on a laser pointer. Pointed at the camera. And here's the cool thing. Let me get the stuff off it. This is a little rolling chassis as a sort of like a toy and a warmer upper for making a car or quadcopter. And what it does is it holds a Adafruit half breadboard that you can buy that are, it's got the pattern of a breadboard and the
Right.
whole spacing almost of a breadboard, but slightly improved in that the outer power supply section is equally spaced from the inner sections, on a 0.1 grid. But anyway, that's a detail that doesn't matter. What matters is I've been getting okay, at least, at making parts fit. I made the circuit board fit with a little frame retainer. I made this battery fit. It just kind of, well, I'm not going to operate it, but it snaps in like into this other one.
Right.
See, one has a battery, the other doesn't. And the wheels roll nicely. They're greased. So we have moving parts, and we have maintainable parts and fixed parts, and parts that fit in together from the print, as well as external parts that fit together. In this example,
is that a design you did, or is that something you found at one of the
no, I made this. I iterated on this for a few days, for a day or two, on my printer.
Okay. Have you posted that? I'd like to play with that.
What?
I said, have you posted that to any of the?
No, you want me to put it on? I don't even know if I have the file. I've been evolving it.
Right.
I'll put it together and post it on Imagine if you want me to.
Please do. Take your time. It's going to be a little while. My printer's not in a place where it can be used at the moment, so it's going to be a little while before I get to play with it. But
Okay.
that's a fairly nice design, and that's a fun breadboard to work with.
It's a fun, cute little thing. I didn't have the motors yet because the motors were in the storage shed. But when I got the motors, I came up with this cute little thing. This is going to be a quadcopter one day when it grows up. It's got a little board holder in the middle, and that holds a quarter size. We're getting to the hand soon.
Right.
A quarter size breadboard with the same pattern on the back. See, gold plated, really nice quality and stuff. And this is what's going to go in the hand, like on the back of the hand or in the gauntlet, is a quarter size board. Anyway, so this, I'll tell you a funny story real quick. I always talk about divine intervention as a component of creativity, and that happened here. If you look at these propellers, what I was working with, I can't reach over there, were really bulky, ugly propellers that my initial attempt, and then I wanted to simplify them. And I didn't know how I could possibly get a propeller shape out of what I had or work with something new. And I said, well, let me clean up the file. So I was deleting unused things, and I deleted all the unused variables, and I deleted just one extra variable that I should not have deleted. And I hit the refresh, and bam, out popped this propeller, which has like a bird-like quality to it, like feathers or wings or something, and it's all profiled like a propeller should be,
Yeah, that is a
And
good.
I'm like, wow, that came out of nowhere.
It's got a beautiful feel to it.
Well, I'm just saying that this stuff happens a lot, and it's not of my doing. And I think for a lot of us, in a lot of aspects of life, that divine intervention is more common than we think. But that's a brief aside. And where I'm going with all this junk is that now I have the pieces, parts, flexible solar cell, and especially these lenses, two lenses, for making that stuff I was talking about putting on the back of a
right, your discussion that we had after the conversation last 2 weeks ago.
Yeah. Yeah, after the conversation we talked about this stuff where
that size lens a lot lately with Google Cardboard projects.
Really? That's a Google Cardboard lens?
Yeah, it's about the right size. I don't know if it's the right focus or the right magnification. I've been using like a 5x lens, which gives me about the right focus for screen right up against my face.
Maybe we could put Google Cardboard on a gauntlet.
Mhm.
But what I was going to do with them was, right here you can see one that's in a mounting
Oh yeah,
fixture that I made some time ago. It has a retaining ring and it holds it. And then that would be on the gauntlet. And I don't have a thermal transistor, but I do have cadmium sulfide cells. So I thought I would put a cadmium sulfide cell here, and then this becomes a light level detector. And I have an actuator that is, it's around there somewhere, I'll find it, that is like a speaker without a cone. Have you seen those things? Sparkfun sells them. But it can vibrate,
okay.
you know. And of course I have resistors that can provide heat.
Yeah.
And so we have a sensor at a distance, we have a processor and the means to program it. I've got that too. And then an actuator. And I guess several people have come in. I'm about done here. I just wanted to report to everyone that the Lab of Less is alive and well and kicking once again. So expect some goodies in the future.
Yeah, we'll expect to see some of that stuff on the forum.
Yes.
Yes, I have been remiss in visiting the forum, and I will
We all have.
do so
Yeah.
again tonight.
I
Yeah.
think my biggest problem using the forum reliably is that PHPB has always been hard for me to get good notifications from when there are updates or when there's activity.
We just
And
figured that out.
yeah, I just saw that note.
Yeah.
That conversation.
The other thing is if you do subscribe to things, I'm testing it out. I'm going to try to find somebody to help me test it out. But it seems to be that not only do you subscribe to everything to get notifications on the actual forum, because there's a little thing like the G+ bell at the top of the forum, but also you have to select email notifications as well to actually get the stuff in your email like we do with Google+.
Right. Yeah, I've used PHPBB forums in the past. It's just been a while since I played with them, and that was always why I stopped playing with them way back in the day.
Mm-hmm.
But they've got a lot of interesting plugins and a lot of interesting tools. So I'm going to start playing around with an app for my phone and see if I can get the kind of prompts to check in that I do with Google+. I like Google Plus's notification system because it shows up everywhere I look, so it's hard to ignore. But
Yeah.
my idea is to make some of that happen with other things. So I've sent a lot of invites to Skip. I'm going to send him just a chat request. And
I think there's a good chance he won't be able to make it. He's on vacation, and I think he probably went ahead with some other plans.
that was one of the things that he had mentioned or it looked like he had mentioned in his comment with his bad news was the part breaking and other things came up. So,
Yeah, I think the other things probably have his attention right now. I'm actually going to go ahead and drop off. I have to go put my son to sleep, but it sounds like we'll go ahead and try this again next time and show the device then. But he's got a cool design to show, so I look forward to it. It's a modification of the Flexi Hand to use it as a terminal device on an RIT arm.
Yeah.
I like that that nut for holding the terminal devices.
Yeah.
I asked earlier that it was a standardized part. Is this a nut that you could just go buy at a hardware store, or is this something?
It is. It is. I just went and got one today. It's a half-inch wide nut, but it's the higher thread density. It's 20 threads per inch, but I was able to find it at my local Ace Hardware.
Nice.
Yeah.
That is good to know.
So I'm going to drop off. Good evening, everyone. I will see you next time.
Oh,
Thank you,
Jeremy?
Jeremy.
Yeah.
I'm going to drop off as well.
Oh,
Right,
well,
yep.
guys, just remember that there is now a terminal devices subforum on the forums.
Yes.
Oh, excellent.
Please add any links to designs that you guys are working on, and if you've got more photographs, go ahead and start some threads. We need to start using that that forum. It's got a lot of good things for us in the R&D because you can post photographs into the comments, and that gives us a little bit more flexibility in how we can use it for discussing things.
Yeah.
Okay.
But,
Well, this is, it's really Skip's design, so I'll let him do the sharing, but I think we're very close to that.
right, cool.
Yeah, I posted a link to the subforum in the sidebar chat.
Yeah.
Excellent. Thanks.
All right, thanks for joining us, Jeremy and Jeff, and good to talk to you guys both.
See you soon.
See you.
Bye.
I'm probably going to have to bail after this, but real quick I wanted to mention, when I'm not doing e-NABLE stuff, I do research with various people at Cornell on slicers, basically.
Okay.
And for the most part, I'm working with 3D layers, so let me switch to my own view here and see if I can get a good picture of this. Oh, yeah, that's pretty visible. So you can see this cube has been made with V-shaped layers on it.
Oh, that's the side, not the front.
Yeah, that's the side of it. So then the other side of it has flat layers because it's a V shape.
Right.
So
Can you scoot it back a little bit? It's not showing up the layers.
yeah,
anymore.
it doesn't render very well. It's just a pretty poor little thing.
So basically kind of herringbone-ish.
Yeah, so each layer is doing this, essentially.
Right.
And there's a variety of cool things I can do with that. This is a surface of one. Didn't go too well on one side because the print failed, but the point that I was trying to show with this piece is that you can make angled surfaces perfectly smooth without stair steps, and there's a fair number of other cool things you can do. So oh, and if this wasn't clear, it works with a totally arbitrary layer shape. So in addition to the mesh you want to print, you provide a second mesh representing the shape of the layers, essentially.
Oh, cool.
So I'm probably going to have some sort of alpha testing thing going on within a month or so, just like a web UI for it.
Right.
So I'll definitely loop some e-NABLE people into that. So I guess just kind of think about how you could use it. I'm doing research to figure out how exactly this affects strength. It intuitively seems like it should improve it in a lot of big ways, but characterizing that is my current work.
Before you go, Nick, could I mention to you something that I had been working on in December, and I'm picking it up again?
Mm-hmm.
It's a distributed control system for a 3D printer. The way it works is you put like a little tiny 85 or 84 processor or like a teensy at each motor, and you can use the extra pins of I/O and the processor time and the memory and stuff to do things like self-test is a major feature. So, you know, the old joke about Scotty running a diagnostic, you can do that. And it allows you to individually control the motors, you know, simultaneously. So it's great for doing stuff like what you're talking about.
Individually control them simultaneously.
Well, I didn't say that very well. You can control the motors individually, and that can be going on all at the same time. So, like, you can, like right now, right with a conventional rep wrap slicer or whatever, whoever makes our G code, you can control X and Y, but Z has to be done in steps.
No,
No, it does full 3D moves just fine with the current versions of, I think, all the major firmwares. That used to happen way back on like 5D, but that got phased out a long time ago because there wasn't ever really a good reason for it. I guess it might have.
Oh, okay. I was told different. I guess that's wrong then.
No. Yeah, the only reason people don't do 3D layers already is that the slicing side of it's kind of a pain. The hardware is pretty capable. I mean,
yeah, you have to do more rotations for up and down for the Z-axis, but
yeah,
the motors are quite capable of
Oh,
rotating.
what about the extruder?
Hmm?
No, that you can do that too.
Yeah.
Yeah. So I mean, I'm doing this on Smoothie Board, but I've tried it on I think Gen 6 and a couple of other older machines, and they've all printed stuff like this, which required moving all 4 axes at once, X, Y, Z, and E.
I tried an experiment. Well, anyway, that doesn't matter. Well, maybe that's not an advantage of the system, but I'm sure you can imagine other advantages besides the self-test. You have lower noise in the system. You're not running stepper motor wires through the whole thing. They're all terminated locally, so that helps for safety. And at some point, we're going to have to deal with UL listing on these printers and stuff like that, right? So, and I think it would probably help with just a lot of different things. Oh, heat was a big one. Heat, so your drivers are not all in one place. Your source drivers are located in a distributed manner throughout the system, so they can be it reduces the number of fans needed, or it reduces the number of fans needed and improves the reliability. So, but I don't know if that would have any benefit to do with any research you or someone else you know is doing, but that's being worked on as a distributed system. Just thought I'd mention it in case it was related.
Yeah, I mean, I'm sure there's some interesting applications. I'd be a little worried about running low voltage signals from, well, to the various places on the machine. I mean, right now you have data coming in through the USB, and then you have your end stops, and pretty much the rest of the machine, you don't really care about how much noise you've got going around, so it doesn't matter too much if the wires are a mess. If you were trying to send step signals down to drivers that were sitting down on the board, you'd potentially run the risk of inducing some weird stuff in there. Pretty unlikely, but
What? Oh yeah, pretty likely, but yeah, I'm sure there are some disadvantages to the system as well. Yeah, whatever they might be. You know, what one might be cost. I mean, with the AT-Tiny approach, cost is about equivalent, but with if you use Teensys or other processors, at each location cost would be higher. But the big selling point is the monitoring for fault diagnosis and that sort of thing. Also, I kind of have the impression that the stepper motors are dramatically oversized in a 3D printer today. Because, I mean, both the printers that I own, I can hold the build table while the motors are active and move it, and the whole printer moves. You know what I mean? I mean, that's some serious force going on, and I think if we had smaller stepper motors, and like a position sensing system, then we could really optimize the system and reduce the cost a lot. Make
Yeah,
more consumer-type product.
you should talk to Fantic. He's on Google Plus. He's what you're essentially talking about there is closed loop control. So
Well,
so servos are the same basic idea. So
yeah.
the reason our steppers are so silly big is that they
Open loop.
steppers are just kind of really weak because you're not. I mean, you're moving in discrete steps. So instead of having, like, this phase of the motor is on, I'm pushing as hard as I can, you have this one phase is on for a fraction of a second to pull the step here, then it's off. So you, the inductance in the motor coils basically give you a much, how do you describe this? They kind of cap out your duty cycle in a weird way, if that makes sense. I don't understand motors that well, but it's yeah, steppers are very wasteful and very, very weak for their size. Fantic's been screwing around with using closed loop feedback, so a position sensing system on much, much smaller regular DC motors, and it's much cheaper, much well, probably about the same accuracy-wise, but much cheaper, much lower power solution for getting about the same performance out of the printer.
How do I contact this guy?
Just add him on Google Plus and send him a message. He's ridiculously active on here. He's one of the admins of the 3D printing community. Here, hang on a sec. Fantic. There he is. And I guess he still works for Delta Maker, which I'm not sure what his role there is, but yeah, they're a hardware manufacturer. Anyways, I should really get off. I have like homework I've been procrastinating on.
Oh,
and a variety of other.
thank you very much.
Okay, bye.
Yep. Nice talking, everybody. Do get in contact with Fantic. He's very interested in that sort of thing. See you, folks.
Okay, appreciate it. That's great. I'm adding him now.
See you, folks.
Okay, bye.
I love it when he's able to join us.
What'd you say, Trouble?
I said I love it when Nick's able to join us.
Hmm.
Yeah, he was fun.
Yeah. So, Jim, you were wondering about printers? You mean everybody's printers, huh? Okay.
Yeah, I was talking about what I don't know that my advice is great because I tend to buy kits because they're cheaper and I can learn more about how everything works as they're building it. But that's not necessarily what other people wants to do. I do like that what I've got are both fairly standard variants of very standard rep wrap designs, but yeah, you have different problems with different models, but a lot of it comes down to learning how it all works in order to fix the problems. For example, if you can get, there's been a model that's been bouncing around a lot lately that is a test print object that shows you how it prints at different angles and at different, with different overhangs and different things like that. And then the rest of it is just making sure that all your belts are tight enough, making sure that you've got the right voltage to all your motors, making sure that you've got the right, that everything is tight enough so that the printer isn't shaking when it's printing. There was a suggestion that, I can't remember who it was, but she posted that putting a piece of carpet underneath her printer made everything vibrate a little less, and that greatly improved the quality of her prints. There's a lot of those kind of things that can be done to improve you're printing, but it's mostly, I think that it's important to know how your printer works so that you know what you're doing when you go to fix problems that you're having. And so I tend to advise people to do kits, but I understand that kits are beyond the expertise range of a lot of people that want to just jump into this and start printing immediately.
Yeah.
I'm of the opposite persuasion, but I agree with everything Trouble said. I mean, I wanted to use a printer to print cool stuff and not be a printer mechanic. I'm being drawn into printer maintenance anyway. So I took the reverse procedure and wound up in the same place. So either way you slice it, you're going to be a printer mechanic, I guess.
It's also most of the complete kit or complete built printers that you buy are in the 2,000 range, and both of my printers together are less than 900. One of them was about $200, and the other was about $700 when I bought them. And it took me longer to get it all put together, but you know, I learned a lot while I was doing that. I know a lot about what's going on inside my printers now that I wouldn't have known if I had just purchased one off the shelf. But yeah, that price range difference is a big deal.
Yeah, it's either you have money or you have time, and the inclination to learn.
Yeah.
I'm working with a guy on a new printer design, actually. It uses either we're planning to add the stuff that I just spoke with Nick about.
Right,
but
with separate driver boards for each motor?
It works out with a standard driver board as well. And he's got it printing. He's got the first one printing. And basically, this thing is entirely 3D printed. The frame and the parts that, like the motor mounts and the various bits and pieces that can be plastic are plastic. And I think it's a beautiful, what Lydia said, a trade-off of time for money. Because you will run a printer for a week to print this printer, but the actual cost of the printer is really very low.
Right. Yeah, most of the Prusos that I've been playing with, they're very cheap to produce, but you need some expensive equipment to make them. Most of what I've got have laser cut wood parts that have to be bolted together with bolts that you can buy at any hardware store, and then there are a lot of rods and rails that are metal that have to be acquired, but most of the kits come with all the parts. It's just the manufacturing is fairly cheap because everything is either cheap to cut because you've got a laser cutter, or cheap to purchase because it's just a standard sized extruded part, or a standard sized threaded rod, or you know, whatever. But yeah, that was the goal of RepRap, is to design printers that can be printed.
Yeah.
You know, a printer that can make a copy of itself. You know, not completely, most of the parts.
Oh, I thought of an interesting phenomenon as recursion in printers along that line. If you can make a printer that prints a printer half its size, and then that printer prints a printer half its size, I mean, how far can you take that?
Oh boy. Well, nanotechnology these days, you'd be surprised.
Yeah, I guess so. Or twice as big. Printer that prints a printer twice as big. I mean, how big can you make it?
Big enough to see from space, maybe?
Since it's not printed in place, it's printing parts. They can keep getting bigger, I'm pretty sure.
So we need is a print-in-place printer.
Right? One that's ready to run as soon as it's done being printed.
Nice.
So Jim, that printer that you just showed us, is that a turntable or is that just a? Because it looks like the X and Y are both controlled by the arm. Yeah, rotating bed. That's kind of reminds me of the. There's been a lot of printers now that have the 3 arms going down to the piece, and it's got they move the head on both X and Y, and then just lower or raise the bed as needed, or lower or raise the each of the arms as it's going up. I don't know. Rotating bed seems. I think the slicer would be interesting. I'm not sure how that would work with G-code. Although G-code is pretty simple, but creating the G-code to control that would be interesting. I don't know. I'm not sure. I'd have to look into it more. I'd have to spend a little time thinking about how that would work. Although 3D printing records would be a lot more fun if you were printing them on a turntable.
No pun intended.
No, the pun was definitely intended.
Oh, okay.
I've just spent, my youngest sister got married this weekend, so I've just spent the entire weekend hanging out with all my siblings, and play on words is the only way we know how to communicate with each other. So, so some of that has rubbed off.
That must be a pretty entertaining family to communicate with.
Yeah, I'm a recovering Mormon, so my family are all Mormon, and as a side effect of that, I come from a very large family. I am the oldest of 7 kids, and our age ranges are from, I'm 41, my youngest brother is 22, so we have, or 23 maybe. So my baby sister got married this weekend, and so that was the first chance that all of us have been in the same place in, oh geez, decades, I think. So it was fun. Most of us made it to my brother's wedding 2 years ago, and but yeah, it's been a while since everybody's been able to be in the same state at the same time, let alone the same town and in the same house, or the same motel even. So it was a fun weekend.
I contacted you and you said, I am at my sister's wedding.
Yeah.
Right now. I was like, whoa.
At the wedding, it was at his parents' backyard. So I had my phone with me. The wedding had finished, but the wedding and wedding after party were at the same location, and so it was kind of fun.
Poor timing.
Yeah.
Or exquisite timing, one or the other.
Yeah, it was fine. I silence my phone when we're at events like that, but I'm almost always ready to respond when people message me. Actually, you guys both talked to me quite a bit later in the evening than that. Most of the people had gone, or we may have already. I think when I was talking to Lydia, we had all moved to the motels again, or to the motel again. So so it was mostly just the conversations were getting pretty thick, so I didn't want to step away from them at that moment. Yeah, my family are kind of nutty.
That's a good thing.
Yeah.
One of my sisters is excited about the fact that she does a lot of CrossFit, extreme exercise things, and she was rated 36th in her region and like 300 and something in the world for her age group. which is kind of ridiculous and kind of matches her. So my next youngest sibling is my sister, and she's a bodybuilder. My next brother is a teacher at the Air Force Academy and worked for Air Force intelligence for the last decade or more. And he's got 7 kids now as well. And they're all a lot of fun to talk to and hang out with and chase around. And there's a lot of photographs of the babies this week.
Unique characters.
And then there's Jared, who is living up in Salt Lake, working. I'm not sure where. I think he's working at a Best Buy, putting his wife through school, and then when she's educated and can get to a job, he'll put her through school. They've been sort of trading off who's in school. But they're wanting to be teachers because they both have some of the most severe cases of wanderlust that are in my family. So they like to, for the summer, they like to run off to a foreign country and be tour guides or take people through zip lines in Hawaii or teach languages to kids in Russia or whatever they feel like doing this particular year. And the rest of my siblings are either babies or disabled. So
I feel like I'm both.
My one brother is wheelchair bound because he's got it's ankylosing spondylitis, which is kind of a spinal arthritis, but in his case mostly hit his knees and ankles and hips to start with, and then migrated into the spine. And so a lot of the reasons I'm involved with this and getting more practice if I can with 3D printing is because I would like to try to work on developing exoskeletons for him to be able to move around a little bit. Yeah, so it's a lot of my involvement here are for either personal reasons or for family reasons. And I like the design. I like the R&D side of this.
Yeah.
I don't know. Do we think that anybody else is going to be showing up, or? Because I'm wandering way off topic now.
Oh, you noticed, huh?
Yeah.
Yeah, I checked the questions and answers. There's no questions that anybody's asked, so.
Yeah, I've been looking at that, and there's not been much going on the commentary either.
No.
So, I don't know. I'm probably ready to go running off.
Okay.
If the rest of you, unless somebody else has something you want to bring up. I'm sorry that.
One thing. You know me, I always got to talk about something.
Yep.
Even if I have to make it up. But
well, at least you got a hobby there, Les.
Yeah, that's my hobby.
Uh-huh.
You all entertained. I've been saying for a long time that I'll be leaving the nursing home and going to a apartment near the hackerspace in San Antonio.
Okay.
For this time, it's really going to happen.
Ah.
Supposedly.
How soon?
Within a month or two.
Okay.
And like a week of that time has passed, so within 3 to 7 weeks, I presume, that time frame. And when that happens, I'm probably going to just, for safety and security reasons and peace of mind also, just leave all my technical stuff. Both of my, what's going to be, I'm going to have 3 printers at that point. My 3 3D printers, leave them all at the space. And I'll have access to a full lab of tools, and they've got a laser cutter, and they've got, they're working on, they've got people who do vinyl cutting and clothing and painting, and they do, they're getting into loss PLA process. You heard of this?
So
I know
that
about lost
yeah,
wax casting.
yeah, I've seen lost PLA. Yeah, where you print something in PLA, cast it in something, ceramic or mud or sand,
Yeah.
and then you melt it out and then pour hot aluminum in instead.
Yeah, just like the lost wax process that
Yeah.
Yeah,
you mentioned,
sounds
the
familiar.
lost PLA.
Mm-hmm.
And, they have lost ABS as well, but PLA is the way to go.
Yeah, PLA, because it melts at a lower temperature and the fumes are a lot less toxic.
That's
Yeah, you
always
can
nice.
melt it out at a barbecue grill. What?
That's always nice for the fumes to be less toxic.
Yeah, but that's helpful. But and the people too, especially. They do a lot of teaching, and they bring in a lot of expertise in areas that I'm not familiar with. So there's going to be a lot more of synthesis. It's almost like going to a university. In fact, I made the observation to I got a sister-in-law who is a teacher, and she talks about getting a box of rocks for her classroom, and how depressing many of the younger generation seem to be, and the way corporate America, or the corporate world in general, and politics are so negative and all this. And I explained to her, I said, there's a lot of truth to what you're saying, and what's happening is auxiliary systems are being developed to handle those problems. Like the maker trend is almost like an educational system.
Mm-hmm.
It is an educational system on
It's,
the side.
it's often said that the next generation is, degrading from our generation and whatever. That's been being said since the time of Plato. And when you actually look at, since we've been able to measure things like intelligence, we've been noticing that there is a trend that every generation has a higher intelligence than the generation before them. Like, you keep having to, since average is 100, you keep having to raise, or rather lower what the numbers are by about 10 points of the IQ scale every 10 years, I think.
Oh.
So the kids are smarter than we were, and it has been continuing to go that way for all of the time that we've been able to measure it. I think that they don't express it in the school environment as much because they are finding ways to educate themselves in other contexts.
Yeah.
Especially with the internet and all the free classes you can get at Con and all the other places.
Right. And then the maker movement and all of the other things that are going on. That's been the fun thing this last weekend, hanging out with all my nephews, has been that they're all very, very bright little kids. I've got one of my nephews is like been doing a lot of things on DeviantArt where he does his paintings and posts them and gets a lot of commentary and a lot of interaction with people, and he's been getting really, really good with his art. And he does a lot of computer programming, and he's in grade school. He's not very old at all, and they're looking at getting him an Etsy shop so that he can start selling things, so that he can start, paying for buying the things that he wants to experiment with next and that he wants to learn with next, and things like that. I hear a lot of people talk about how the next generation is not as bright as the previous one, but I don't see any personal evidence of it. I see quite the opposite, in fact. Every generation seems smarter than the previous one by quite a lot.
Yeah.
He needs a lot of. Oh, go ahead, buddy.
I know the amount of things that teenagers have learned by the time they're like 19. I mean, it's crazy, I mean, all the learning curves these days, man, all the smartphones and the all the different things on the internet and stuff that people do, and they learn them at a very early age. And I mean, parents let their kids play with their phones all the time and their tablets and everything, so they're learning some of these things before they can even speak. Talk
Yeah.
about digital natives.
Yeah.
Well, yeah, that's interesting. That she, my sister may be observing kids playing with their phones and looking at goofy YouTube and stuff like that. And what she doesn't realize is they know how to work a phone.
Yeah, they're
Really
They
good.
know how to edit videos and put them up on YouTube.
Yeah, and make them look real.
Yeah, Jim, and people using the internet to raise themselves while they are kids.
Yep.
Yeah.
In the sidebar, you said internet raising kids.
Huh.
Yeah, it's I got in a lot of trouble when I was in like middle school and early high school, because I would be researching things in books while the teacher was giving his lectures. I'd be following what the teacher was saying, but he would say something and it would get my curiosity about something, so the next day I would come in with books to read about whatever he had mentioned the week before, and he wouldn't notice that me sitting in the back reading had anything to do with what he was talking about. But yeah, I got sent to the principal's office once for reading Plato's Republic after he had mentioned the class before that one of the founding fathers had written in an article about how he had read the Republic in 5 different languages and it didn't make any sense to him in any of them. And so I would look at it to see what was wrong with it. And yeah, that's a book that it's on the list of books that the first time I read it, it gave me headaches, because the logical fallacies that Plato falls into while writing it are things that there's no reason he would know that they were fallacies at the time he was writing, but now they definitely are. And it was an important book to read to learn what fallacies humans tend to fall into, and how really smart people can get caught up into really simple logic mistakes. Yeah. So I think we can keep chatting, but I think I'm going to take the broadcast offline.
Okay.
I'm sorry that Bob was unable to join us tonight. It sounds like he was having some connection problems. I don't know if it was a network thing or if, I don't know, I'm not sure. But he's appears to be on, but he's not been able to get connected. We've been chatting in the background a bit about it. So I'll try to get a hold of him again later on. And I think we covered everything except what I actually talked about doing in the description of the week's Hangout. And we did a little bit of that in the sidebar because Lydia was posting links to the different forum sections that have relationship to the topics we were talking about, mostly the term ones. So I'll copy a lot of that stuff and plug it into, I'll copy everything in the sidebar chat into a comment on the post rather than doing a Google document this time.
Yeah.
If that doesn't work, I'll have already copied it, so I'll be able to do a Google document as well.
Okay. Sounds good.
All right. So.
Did I talk too much?
No.
Okay. Well, I'm going to fly away.
All right. Have fun with that. That's